As we wrap 2025, it's time to reflect on how things went, and we should prepare well for the upcoming year 2026. We are surrounded by intelligent and smart connected systems, which have three elements at its core. These systems are silicon-powered, software-defined, and AI-infused. The old ways of working in terms of having physical prototype as the gold standard are all gone. Now it's digital first and physical second. Whether we are building spacecrafts, data centers, semiconductors, or even life-saving medical systems or consumer electronics, the transformation in how these products are made is truly important. It is the best time for all of us to play an active role as a technologist. And frankly, it is probably a consequential time for all industries in this century. The silicon-powered systems of today require a different set of technologies for simulation. Multiphysics and multiscale is super important. Most of these intelligent systems have silicon at its core. The silicon transformation has been significant in 2025. The traditional norm of scaling transistor-level technologies has changed to putting multi-die architectures in place. These heterogeneous multi-die architectures involve a combination of technologies at different process nodes that are put together. So with respect to the physical phenomena of signal integrity, power integrity, and thermal-related stress and mechanical effects on the silicon, it's quite significant to do multi-physics simulation engineering. Today's cars are literally like a computer on wheels. If you look at the key trends in electromobility, ADAS, and autonomy, as well as the software-defined vehicle, I think it requires a lot of systems level integration and testing and validation. I'll give you an example of a Sony camera technology, like the sensor technology and the camera technology, which sits at the very lower end of the system of systems path, which gets into a Denso module, which gets into a Toyota or a Honda car. One has to validate the design and its performance and throughput and capabilities before even the semiconductor of the sensor is designed and manufactured. So this whole notion of integrating across the supply chain and then innovating and integrating various levels of innovation is super important in 2026. Going into 2026, I think the technology strategy has evolved for us as well. In the semiconductor and electronics industry, everybody's going after these heterogeneous multi-die architectures, so bespoke silicon is big. I think addressing the multi-physics and multi-scale challenges for bespoke silicon is top of mind for us. In addition, I think the entire semi-manufacturing and electronics manufacturing processes is also truly transforming. I think it has to do with the supply chain constraints, but at the same time, most companies are now building in some level of strategic autonomy by region, by country. Supporting the new workflows, new processes requires a completely different mindset. I think it has to do with understanding what their as-is processes are, how the to-be processes would be, and then create some transformation plan. And most semiconductor and manufacturing related to electronics is going through that cycle at this time. In terms of the automotive sector, ADAS and autonomy and software-defined vehicle, and even the traditional vehicle development process is transforming. There's a lot of innovative technology that is coming into play. I mean, look at ADAS and autonomy today. It's operating at L5 level sometimes in the US, and rest of the market is developing beyond L3 level systems. It's very, very exciting to be in this time. In terms of aerospace and defense, I mean, we are always surprised by the number of launch vehicles and the number of satellites being placed into orbits, the low Earth orbits, as well as the geostationary orbits. I think over time, you'll see more and more exploration of space continue, and it's an exciting time to be associated with the space industry. I also see a very good amount of collaboration across different space agencies between India, Japan, Korea. Simply amazing to see boundaries being broken and technology partnerships evolving. In the industrial sector, manufacturing sector, I've been a big fan of something called asset performance management, where you can design an asset, manufacture an asset, and then operate an asset. And in that continuum, having the ability to have a digital equivalent of the asset, a digital twin, visible that gives you operational stats and helps you physics-based simulation to optimize its usage, those are things that will transform the way efficiencies are brought about, be it maintenance efficiency or operational efficiency or even energy efficiency. And new renewable sources of energy are getting very popular in parts of the world where we can actually be engaged in and help that industry transform. Personalized care is something that has evolved quite a bit in terms of providing the ability to address the needs of a certain demographic or even an individual. The technologies related to simulation play a very active role, not just in the pharmaceutical sector. I think in terms of the heart being a mechanical pump, you can actually understand the flow, the finite element analysis of the structure of the heart to figure out where a particular stent needs to be placed and how it needs to be placed. So a lot of innovation in that space. So across semiconductor and manufacturing in electronics, across automotive sector, healthcare, industrial, and even space and defense, truly a transformative time. So it's an exciting year ahead for us. There are many areas where we are diligently focused on. One is, of course, advancing the physics-based solvers, making them better meshing, multi-scale, multi-physics capabilities. But at the same time, the ability to compute and run these jobs very efficiently and effectively requires high-performance computing capabilities as well. So in fact, I just came back from the supercomputing conference in St. Louis and excited to see how memory sharing, messaging, and some of the technologies related to quantum are taking off. So we are investing significant amount of time and energy into it. AI and machine learning is not new. Most folks understand and see the impact generative AI has made. Now we are getting into more optimization and more foundational models which are physics oriented. So we are working on large physics foundational models. In addition to that, I think the experience that an end user gets with respect to using these multitudes of tools, it requires interconnect and interplay between different applications. So having an open API surface and having tools like Ansys to engage with other applications and move data seamlessly is another area of focus, improving the user experience on how an engineer can use these tools. Frankly, transitioning from engineer to make sure that these engineering tools can be used by everyone, generative AI and other ways of engaging AI tools on the front end with natural language processing is another area of focus. We are always so excited about bringing new technologies to market and transforming with the help of technology. But one aspect that is kind of overlooked is the process transformation. I think process re-engineering and bringing in a new way of working is super important, especially because of these new time to market and complexity constraints that we face. Most products are more complex. The windows to delivering a new product is shrinking on us. When it comes to optimizing the workflow, one has to use tools like digital engineering and bring in new practices like model-based simulation engineering, do systems architecture modeling, and all the tools need to be effectively used to transform the business process. We talked about technology transformation. We talked about process transformation. But I think the most important element of all of this is engineers and people like us who use the technology. So skills development is the cornerstone of a successful organization. Most of us need to double down in our efforts to build new skills, develop new areas and domain expertise. Everything is becoming more multidisciplinary. I think having an electronics engineer work on a problem that involves thermal and mechanical warpage of the silicon requires some knowledge of mechanical domain. So having a cross-domain expertise is critical to success of these organizations. So skills development all the way from university level to high school level is super important, and an effort around curriculum management, training, and continuous development is required. Also, something called concurrent engineering is a very important phenomenon these days. You have to get these multifunctional teams together into one room, developing something together and collaborating in a concurrent way to develop faster and get a better TTM. As we wrap 2025, we are very grateful to our customers to bringing these cool innovations to market and involving us in their journey of innovation. This trend of having systems of systems across all industries is going to be pervasive. One needs to focus on technology, at the same time on processes and people and skills development. I think in the coming years, the innovation across people, process, and technology is required for success. Multi-physics, multi-scale is going to be the norm, and simulation engineering and digital prototyping and virtual prototyping is going to be key to all of our success. So in summary, physics-based simulation, multi-physics is cool. We got to do more of it. Silicon to systems is a pervasive theme across all industries. So look at things holistically at a system of systems level. So systems architecture, systems dynamics, all of these are very important elements to consider. We have to rethink the processes, as I mentioned, digital engineering, leveraging design thinking. All of that is important because it's always three vectors: people, process, and technology. Skills development being an important focus. Co-innovating with the ecosystem is the cornerstone of product engineering. I think, like most every industry, there are supply chains, there are multi-partners involved in the development of a product. We need to work collaboratively and believe in ecosystem play. Everybody has to collaborate and work together. Thank you for your partnership. I look forward to 2026.